This video, we're going to learn about designing robust network infrastructures and how we can go about securing those networks. So when we talk about network architecture security, we're talking about structuring our IT networks to protect data, applications, and users who are using and interacting with that network. As part of this architecture, we incorporate principles like zero trust, segmentation, and secure communication protocols to build in defense in depth and defense in breadth into our networks. All of this helps organizations mitigate cyber threats, reduce attack surfaces, and enhance network resilience. But designing and building these secure networks is not necessarily easy. So why is network security important, and why do we need to go through the effort of building these security mechanisms into our network? Well, network security helps prevent cyber threats that exploit network vulnerabilities to gain unauthorized access. This means that all of our data and operations rely on the network security to keep them safe. And having these secure architectures reduces the risk of data breaches and service disruptions, which increases the efficiency of business operations, keeps our customers safer, improves our overall reputation, and reduces cost. In addition, compliance with various regulations like NIST, GDPR, CIS benchmarks, and more require certain levels of network security and certain implementations of security controls. So implementing these security architectures is a requirement if you need to comply with these regulations. When it comes to designing secure network architectures, there are a few key principles that we can follow. The first is segmentation and microsegmentation. So we want to avoid a scenario where we have one single flat network. A flat network refers to a network in which every system exists in the same part of the network and they can all communicate to each other. This means that if a single system or component of a network is compromised by an attacker, then they very likely have access to your entire network and every system interacting with it. With segmentation and microsegmentation, we keep systems compartmentalized to the parts of the network that they need, and we don't let them communicate with parts of the network that they don't need to. By ensuring that our systems only have access to what they need and nothing more, we help protect our other systems in the event of a compromise. If an attacker gains a foothold on one system, they don't automatically get access to every other system. We also want to use virtual private networks, or VPNs, wherever possible if there is something like remote access to our network or communication tunnels being established. This will help ensure that we protect our data in transit when it's being sent across potentially unsecured networks to our network, thereby reducing the likelihood of data or credentials being sniffed out and compromised. And by establishing secure communication tunnels between systems, we can help control who and what connects to what systems. And we also want to implement zero trust networking, which effectively means we don't trust any user or device by default, regardless of whether that user is coming from inside of the network or outside of the network. With zero trust networking, we're performing things like authorization and authentication on every request, granting only the access that's needed to certain resources based on a user's need or a system's need, thereby continually verifying that every user, device, and application that's trying to perform an action on our network is allowed to do so before permission to perform that action is granted. These three key principles can go a long way toward building and designing a secure network architecture. So what are some technologies and tools that we can use to help us when implementing these architectures? One helpful tool available to us are intrusion detection and prevention systems, or IDS/IPS, which can help us detect and respond to intrusions or cyber events in our network. Next generation firewalls, or NGFWs, which can help control communication to and from as well as within our networks, and then analyze that traffic and perform more intelligent computations and analysis around that traffic. And Secure Access Service Edge, or SASE, which is a network architecture that combines both VPN capabilities with cloud security capabilities, incorporating things like secure web gateways, cloud security brokers, firewalls, and additional zero trust network access capabilities, giving us more granular control over our access. And when it comes to network security architecture, there are some best practices that we can follow. The first best practice is to implement least privilege access, and this follows zero trust principles. We don't want to grant any more access to a user or a system than we have to. If a user only needs access to read a certain database table, they should not be given read and write access to the entire database. We also want to execute continuous monitoring and threat intelligence. This is where our intrusion detection and intrusion prevention systems, along with our other security tools, are going to help and provide us with this intelligence, and ensuring that we are continually logging and monitoring all of the actions in our network will also help us build up our threat intelligence and control and secure our networks. And define and enforce secure connectivity policies. This means implementing policies like minimum device security standards that are required before allowing connection to the network, as well as what kind of communications and protocols are allowed on the network. Following these best practices will help ensure that you have a secure design when implementing your network architecture.